Hi children, in today's lesson we'll cover the topic of fractions. Let's start with the definition of a fraction first and then focus on what it means with shapes. In maths, a fraction is used to represent the portion or the part of the whole thing. After hearing whole thing, there is a question coming. This question is the following. What is the meaning of whole thing? A whole thing may be a food that you will eat. Maybe amount of money that you will spend. And maybe a job that you should finish. I think you understood. A fraction represents the equal parts of the whole. Now, you suppose that you and your friend, it means you are two, are hungry and you will eat pizza. And there is only one pizza. What will you do then? How you will share it? Of course, you will divide this pizza into two equal parts. Then each part is equal to half of the whole pizza. And two parts in total are called halves. One of them is the half of the whole. Okay? Now let's give another example for halves. Now I have a rectangle as my whole and I divided this whole, this rectangle, into two equal parts by sketching its one of diagonals. And let's denote these pieces with 1 and 2. These two pieces are equal to each other and one of them is the half of the rectangle or half of the whole. These two equal parts are called as halves. What about this figure? It's very nice. Heart. And the heart was divided into two equal parts in the figure as you see. Let's denote these two parts with 1 and 2. They are equal to each other. One of them is the half of whole. Half of the whole. Half of the whole. Whole means here heart. And these two parts are called as halves. What about the last figure? I have a regular pentagon here. And it divided into two equal parts. Let's denote it again with 1 and 2, these two parts. Each part is the half of regular pentagon or half of the whole. These two parts or two pieces are called as halves. I think you understood the meaning of halves. Now let's continue with again the pizza. Now you are not two, you are three. You and your two friends. And you have only one pizza. What will you do then? You will divide into three equal parts or pieces this pizza. And each is the 1/3 of all pizza. And these three pieces are called as the thirds. Give another example on the next page. Thirds, our next title. Now I have a circle and I divided this circle from its center into three equal parts. Let's denote these three parts, equal parts, with 1, 2, and 3. These three parts are equal to each other. And each part is the 1/3, 1/3 of the whole figure or circle. These three equal parts are called as the thirds. What about the next picture? I have an equilateral triangle and I divided this equilateral triangle into three equal parts. Denote Let's denote them with 1, 2, and 3. These three parts are equal to each other, and each of them is 1/3 of the whole figure, or equilateral triangle. These three pieces are equal pieces are called as thirds. Okay, and now you are four, you and your three friends, and you have only one pizza, so you will divide it into 4 equal pieces. Each piece is 1/4 of the whole pizza, and these 4 equal pieces are called as fourths. Give another examples for this. Fourths. Now in the first picture I have an equilateral triangle, and I remarked midpoints of all sides of this triangle, equilateral triangle. If they are the midpoints, and if you connect them to each other, you will get another triangle inside of equilateral triangle. Now I have 4 triangles. If these are midpoints, then these 4 triangles are equal to each other. Each, let's denote them with 1, 2, 3, and 4. Each of these 4 equal triangles is 1/4 of the whole picture. And all these 4 pieces are called as fourths. What about the second shape? In this shape, I have a square in total, and I divided this figure into 4 equal triangles. Let's denote them with 1, 2, 3, and 4. One of them, I colored here, one of them is 1/4 of whole figure, or 1/4 of the square. And these 4 equal rectangles are called fourths. Okay, fourths. What about the last figure? I have an ellipse, and I divided into 4 equal parts this ellipse. Let's denote them with 1, 2, 3, and 4. I have 4 equal pieces now. And one of them is 1/4 of whole ellipse. And these 4 equal pieces are called as the fourth. Okay, I think you understood very well. So we learned up to now halves. I have 2 equal parts. I divided into 2 equal parts the whole. And thirds, I divided the whole into 3 equal parts, and the fourths. And here I divided the whole into 4 equal pieces. I think you understand. Don't forget, please, these definitions. Now I think slowly you are getting better on this subject, and you are understanding where the meaning of fraction. Now, of course, for a fraction, I have some terminology. Here, numerator and denominator. If you have a fraction, numerator and denominator are the most important terminologies, or the words for a fraction. If you have a fraction, then you should know the numerator and denominator of the fraction. Now, let's write a fraction. 2/5. Now I have 2/5 as a fraction. And a fraction has 2 parts, namely numerator and denominator. The number on the top is called the numerator. Okay. Now the number on the top is 2 here. So 2 is here our numerator. And the number on the bottom is called the denominator. So 5 is at bottom, so 5 is denominator of this fraction. Denominator. Numerator. I think you understand. When you see a fraction, you may tell what the numerator is, what the denominator is. Now, of course, numerator and denominator, they have very important meaning in a fraction, for a fraction. What is the meaning? What's the meaning of numerator? Now, the numerator defines the number of equal parts taken. The number of equal parts taken. Whereas denominator defines the total number of equal parts in a whole. Now let's try to understand on this fraction 2 over 5 the meaning of numerator and denominator. I should have a whole. If I have a fraction, I should have a whole. Now let my whole be a rectangle. It's not regular. Suppose it is regular, okay? Regular. Rectangle. Now, 5 is this fraction's denominator. What's the meaning of 5? 5 defines the number of equal pieces, all equal pieces of the whole. So it means for this figure, I divided this whole into 5 equal pieces. 1, 2, 3, and 4. I have now 5 equal pieces. What about 2? The number of equal pieces taken. For example, colored. Now let color 2 of them. I colored 2 of them. I colored 2 of 5 equal pieces. Now, did you understand the meaning of 2 and 5 here? I think you understand. So let's continue with the next page. On the next page, we have an example, very easy. In the first example, fraction given, 3 over 4. What is numerator? Numerator is 3, denominator is 4. What's for the second one, the meaning of 7? Numerator is 7, denominator is 9. If your fraction is 2 over 6, what's numerator? 2 is numerator, 6 is denominator. If your fraction is 1 over 5, what is numerator of this fraction? 1. And what is denominator of this fraction? 5. I think you understood. And you may solve this type of questions easily. You should memorize. And you should understand the meaning. Okay? For numerator and denominator of a fraction. Now, types of fractions. Proper and improper fractions. Now, let's give examples. Try to understand the meaning of proper and improper fractions by giving examples. 2 over, 2 over 3 now is a proper fraction. Why? Because its numerator is less than denominator. So, a proper fraction is a fraction whose numerator is less than denominator. Okay, so 2 over 3 is a proper fraction. It's enough to be the proper fraction for this definition. Now, what about improper fraction? Improper fraction is a fraction which is the inverse of proper fraction. So it means its numerator should be greater than or equal to its denominator. So 4 over 4, they are equal to each other, numerator, both numerator and denominator. Or 6 over 5. Now, numerator is greater than denominator here. So the first one is this, a sample, only the sample for proper fraction, and these two fractions are samples of improper fractions. I think you understand the meaning or the definition of proper and improper fractions. Let's come to its questions. Now, we should match. What's 3 over 9? 3 is less than 9. Numerator is less than denominator, so it means it's proper. What's 8 over 5? 8 is greater than 5. It means numerator is greater than denominator. It's improper. What kind of fraction 4 over 10? It's proper because its numerator is less than its denominator. What's the type of 7? What kind of type? 7 over 6. What kind of fraction? Numerator is greater than denominator, so it's improper. What is the type of 4 over 7? It's proper. I'll not repeat this reason. What's the type of 9 over 4? It's improper. That's okay. I think you understood very well. Like and unlike fractions. If I am speaking on like and unlike fractions, I should have more than one fraction. And for example, 3 over 7 and 4 over 7. Their denominators are equal to each other. Because of this fact, they are like fractions. What does it mean, the meaning of fraction? Like fraction. Like fractions are fractions whose denominators are equal to each other. So what's the meaning of unlike fraction? After learning the meaning of like fractions, it's very easy to tell the meaning of unlike fractions. Fractions having different denominators. For example, 3 over 7 and 5 over 8 are unlike fractions or not like fractions. Unlike fractions. I think you understood well. Let's continue with the next questions. Identify the set of unlike fractions from the following. I should find the fractions whose denominators are different from each other. On choice A, we have this. What about the second one? Which of the following pairs of fractions are like? Like. I should find the fractions whose denominators are equal to each other. Choice B. In choice B, I have two equal denominators. What about the third one? Which of the given pairs of fractions are not like? It means unlike. Unlike. Whose denominators are different from each other. Choice C. Okay. So, I think you understood well. Let's continue with the next one. Mixed fractions. A mixed fraction is a fraction which has two parts. And one of the parts of this type of fractions is whole number, and the second one fractional part. And we denote a mixed fraction with letters A and B over C. It means A plus b over c. Now, in this example, a is called as the whole number of mixed fraction, b over c is its fractional part. So what about the questions? Our mixed number is 9 and 5 over 6. The whole number of this mixed number is 9 and the fractional part of this number is 5 over 6. What about the second one? 3 and 9 over 11. The whole number of this mixed fraction is 3. The fractional part of this fraction is 9 over 11. Well, now a is the whole number, b over c is the fractional part of the mixed fraction. From our previous examples, we wrote like this up to mixed fractions. Only fraction, like only fraction without whole number. 2 is less than 5, you know. Now 2 over 5 is less than 5 over 5. 5 over 5 is 1. So 2 over 5 is less than 1. So what is the type of 2 over 5? 2 over 5 is a proper fraction. If I have a proper fraction, then it means it's less than 1. All proper fractions are less than 1. And of course, this is for positive numbers. And after that, you may write example 7 over 5. Now, numerator of 7 over 5 is greater than denominator. 7 is greater than 5. If 5 over 5 is 1, a fraction may be a division operation. You are dividing numerator with denominator. 5 over 5, so you are dividing 5 with 5. It means 1. The result is 1. So 7 over 5 should be greater than 1. Now, let's make this division if it's a kind of division. 7 with 5. In 7, I have only 1 5. 1 times 5 is 5. 7 minus 5 is 2. So I have a 1. I have a whole number or integer number, positive integer, 1 and 2 remainder over 5. It means in 7 over 5, I have 1 5 exactly, and the remainder is 2, and I am dividing remainder again 5. 2 over 5 is the fractional part. So, you know the definition or the type of 7 over 5. What's the type of 7 over 5? What kind of fraction? Of course, improper fraction. And you changed this improper fraction, namely 7 over 5, to a mixed fraction. There is another subject for us. So if you have an improper fraction, then you may change it into a mixed fraction, into its mixed fraction form. And the reverse operation is also possible. If you have a mixed fraction, then you have an improper fraction. Now, you have just learned how you change an improper fraction to a mixed fraction. Make division operation, okay? After that, let's try to find a solution for the mixed operation, reverse operation, sorry. How you can change a mixed fraction to its improper fraction form. Now let's introduce. Multiply the whole number of mixed fraction with its denominator of the fractional part of it. 1 times 5 is 5 plus add 2 its numerator, and then divide again with 5. So 7 over 5, this is the reverse operation. From 7 over 5, I reached 1 and 2 over 5. From 1 and 2 over 5, I reached 7 over 5. This is our another subject. We should know how we may change a mixed fraction to its improper fraction form, or improper fraction to its mixed fraction form. Don't forget the methods. Okay. Now check the correct option on the next page. The first one, we should tell yes or no, or true or false, like this. 6 and 1 over 7 is a mixed number. Yes, it's true. 3 over 11 is not a mixed number. Yes, it's true. 3 and 4 over 5 is not a mixed number. It's wrong. No, it's mixed number. 8 over 3 is a mixed number. No, it's not a mixed number. It's an improper fraction. Okay, now let's continue with the next one. Unit fraction. Unit fraction is a fraction whose numerator is always 1. 1 over 2, 1 over 3, 1 over 100, for example. These are all unit fraction. For example, for 1 over 3, I have a whole. For if you are speaking on a fraction, you have always a whole. Now let my whole be again a rectangle. And what's the meaning of 3? Divide this rectangle into 3 equal parts. Each part is 1 over third of the whole, and all these 3 equal parts are called as thirds, you know, from our previous titles. Now, what is the meaning of 1? Color one of them. So I have a figure, or for this figure, I have a fraction for colored region, 1 over 3, and for non-colored region, I have another fraction, 2 over 3, because I didn't color 2 pieces of the whole. This 2 represents this. The meaning of 2 is the number of non-colored pieces, and 3 is the all pieces, you know. Now let's continue with the next. State whether the following statement is true or false. 1 over 3 is a unit fraction. Yes, it's true. True. 7 over 10 is not a unit fraction. Yes, true. 4 over 9 is a unit fraction. No, it's wrong. 1 over 9 is a unit fraction. It's false. Now, this nice lesson is over. I hope you understood everything and subject, every titles, every meaning on this course. Hope to see you soon. Hope to see you on the next lesson. Bye.